DNA in space.
Okay.
So, I'm gonna ask you guys a little question about DNA, just to start this off. And the question that I want to ask is how different is your DNA from someone else's?
Is this a rhetorical, or is this a...
This is a real question. I want you guys to ask, just for context, right? Just how much DNA there is.
Okay, do we want like a number or like
you could do a percentage or something, but let me give you some context.
37%.
Let me give you some
All right.
context. So we have 3 billion base pairs that make up all of our DNA, which come from the 23 chromosome pairs that we have. So that's one from each of our parents. It's 46 chromosomes. And all of those give rise to the 30,000 genes that we have in our bodies, right? So the question is, from me to Dylan, or from you to me, how different is our DNA? Or how much is the same?
I don't. Awesome, incredible.
Very similar?
Give me a percentage.
I gave one, and then everyone laughed at
37%. All right.
How many fuck else is a percentage? Like, does someone else want to help me out with that?
So you'd say 37%, the same or different?
Same.
Same. All right. Raise your hand if you think Dylan is right.
I
If
will
you
take
agree
this
with
personally.
Dylan.
Wow! Okay, so
All right.
this is about as many people as wanted to hear Dylan talk about Godzilla.
All right, Alex.
Well, I think I actually know this. It's like 99.9, right?
It is over 90. Yes. So
Okay.
it's over 99.9%, similar to everybody else's, right? But so the question is, how is that possible? Which means, so of 3 billion base pairs, it's about 14 million single little nucleotides that are different, that make us all different. The question is, like, how is it that such little amount makes us so different from each other? So what I'm going to talk about now is actually a very good example of how different we can be just from one single difference from one person to another. And these are called, actually, we're going to get to what they're called in a second.
They're called
First,
Q-tips?
We're going to...
Because you're supposed to not use those in your ears. That's what I know about that.
I want you guys, I have some goodies in here that I want you to go and grab out. Each of you is going to grab one.
Okay, should we look, or is this...
You can look and grab it.
All right.
Oh, fuck. Oh, no. What is this supposed to do? Oh, man. Okay. Oh, boy. All right, so you got that one. Actually, all right, I want you to grab the other one out, Alex.
Okay.
From in there. And we were going to start with the Q-tip, okay?
All right.
All right, so what you're going to do with this, you might need a hand. You're going to use the Q-tip.
On.
Yeah, you're going to go out and get a little bit of, oh, boy.
I don't...
Wax. You can do Dylan's too.
What? No.
That's a level of intimacy I'm not ready to traverse with my friend Dylan.
I did kiss you last time.
That's true. Anybody who's here with Dylan
going
kissed
on?
me?
Yeah, we don't really talk about that.
All right.
What is this?
We'll get there in a second.
Okay, so in my ear?
Yeah, I want you to get a little bit. Hope you didn't clean it out too much.
If I was in the audience right now, I'd be squeaking out so hard. Whoa. You know what? It feels really good, actually. This is an intimate thing to do in front of an audience. I got a little. Is that enough?
Yeah.
Okay.
Just describe it for me.
Gross. Yellowish.
Okay.
Okay.
Do a little bit better. Come on.
It's like kind of like a crayon. It's got like a crayon thing to it. I'm sorry. Oh my god. I'm so glad that I'm in a relationship right now, because I was in like 4.5 years in. I would never find a mate after doing this. It's crayony, yellowy. It looks like what a child would color the sun with.
So my question is, all right, raise of hands if they would also describe their earwax like that.
I like the honesty. I do. I appreciate it.
Way more people are comfortable talking about their earwax than talking about Godzilla. That's what we want to do. Guys, and that's science. Thanks for
I
coming
guess I
to the show.
shouldn't be passionate about anything. All right.
Okay, so what I'm trying to get at, if that would have actually worked, was that there are two different kinds of earwax. There's the earwax that you have, which is called wet earwax. Does anybody here have dry earwax?
Clap if you have dry earwax. I don't know what the fuck that means.
Or don't clap if you're ashamed of yourself.
So now, do nothing.
All right. So nobody clapped, but I know for a fact that Alex's girlfriend is here in the crowd, and she does have dry earwax.
Why do you know that about my girlfriend?
Because I asked her. Do you not know that about your girlfriend?
I'm not into earplay, dude. It's really, like how squicked out I was about my own earwax, you can probably tell it's not my favorite bodily function.
So, the reason why I even thought to ask her is because wet versus
You're a
dry.
creep.
And also that wet versus dry earwax is determined by a single nucleotide difference between you and your girlfriend. There's one single nucleotide in your body that determines whether you have this or not. So again, remember I was talking about how differences, very, very small differences, to the fact that it's just one of those million differences between us will cause this characteristic. And as it turns out, for geographic reasons, almost everybody who is born in the US has wet earwax, and almost everybody that's born in Asian countries have dry earwax.
But my girlfriend's parents were born in Asia, but she was born here.
So, good observation.
That's why
Inheritance,
I host this
Alex. So, let's actually, and so here's this is from a paper that is part of the gene, the ABCC11 gene, which has these differences, which, and it's this little place that's highlighted in red. You can see on the top line, it's wet earwax. There's a GGG sequence, and then for dry earwax, that G is just replaced with an A. That's literally the difference that causes these two things. Okay?
Okay.
So,
I mean, for the sake of the audience, like this looks like nonsense, right? Is that just me?
It looks like a Konami code, kind of.
A little bit like a Konami code.
Yeah.
So what do the letters mean exactly? Like,
the letters are what are called nucleotides, which make up your DNA.
okay, all right. Maybe I just missed that. Like, all right.
No, good question. Okay, so the main thing to notice is that those differences are what causes differences in us, and only one difference is needed that determines wet versus dry earwax. Okay. All right. So talk about inheritance. Why does she have wet earwax if she was born here? Okay. So it has to do with strictly inheritance. So the question is. My question for you is, and everybody else can answer as well, will Alex's babies, what are the chances Alex and Michelle's babies will have dry earwax?
I want to ask another question. What are the chances? This is presumptuous as hell. You don't know the choices. Just because you are a happy father, maybe I love what you're doing with Aiden, but it doesn't look like it's right for me.
Hypothetical babies.
They're cute. They're
dry earwax. So, another percentage.
Okay, well, people really, okay. I say it's a 50% chance that the baby will have dry earwax and 50% it will have wet earwax.
I'm going to say that it is a 100% chance that it's one of them. Because I remember Gregor Mendel, and I just remember he had a funky name, and that's it.
Wait, actually, does anyone else have an answer? You can shout it
But
out.
anyone who's not a scientist.
The chances that, just shout it out. The chances that
Okay, percent chance that...
baby will have dry earwax.
Okay. Zero.
0%.
Any other numbers?
37?
Hell yes.
That was a callback.
I got a fan. All right, so what's up?
He also raised his kid to be funny.
Thank you, 9-year-old. Okay, so we can figure this out only because it is a single nucleotide difference. And if anybody remembers Punnett squares from school? Oh, yeah. Okay, so Punnett square is just an easy way to figure this out. So so the key here is that there is a legend that, remember, we inherit 2 chromosomes from our mom and dad. They give us those letters. And so, for example, you either have GG or AG, right? One from your mom, one from your dad,
Right.
okay? Michelle, only one here causes dry, which is AA, so she has to have AA, okay?
Okay.
So you can do this little square, and then you can cross them, and you can figure out the chances of what your children might have. So if we look at the first upper left quadrant, Michelle's on the left, you are on the top.
Yeah,
So
I know how to read a graph.
if we cross those, AG, right? So what characteristic is that?
Wet.
Wet. All right, and if we do all the rest of them, they're all going to have AG, right? So
I don't want to say it, but that's going to be a wet baby.
0% chance that your child would have wet earwax.
Okay.
Or sorry, dry earwax. This guy.
Oh, wow, fuck, you were right. I thought you were just seriously fucking with me. You said 0.
So the question is why does why does Michelle have wet earwax? So it's for the same exact reason.
Okay.
So the fact that her parents have dry earwax means that she can only inherit dry earwax. But if your baby's baby decides to also have a baby with a Korean woman,
Or a Korean man.
or a Korean
I
man,
might have all daughters.
because that's true.
I'd be a happy father, have
You
all
would be a
daughters.
happy father.
Because I'm progressive.
And if we do this one again, it would actually be a 50% chance
Oh, okay.
that your baby would have dry earwax.
I feel like you learned something. I was really nervous I was going to have to drink whatever the fuck this was, and I'm so happy that's not what this was.
Not yet. I will ask you to smell it, though. Let's do that right now, actually. Go ahead and smell it.
Yeah,
And
I put something in my ear. You have to do this on your own.
So just go ahead and describe it for me.
I don't know. Chemically? Like, I don't know. I'm not saying
Would you
that's
say
a
it's
file,
like-
I'm not an idiot. I just actually mean that
Like good, bad.
it's like very neutral. I wouldn't want it as a candle, but
And look, and remember, so this is about...
that's a good explanation. But if you wouldn't want it as a candle. Alright,
So there's going to be variation in this because this is have to do with just one little difference in our DNA, which causes differences in how you're smelling this.
Smells like kind of like food.
Okay.
What if I drink this? Do I die?
No, you wouldn't die,
You
but
will eventually die. I hate to break it to you, but
That's a
this
good
is a
point.
science show. You're gonna die, Dylan.
Alright, well maybe someone else sniffs it.
Alex.
Alright. I think I smell what Dylan smells. Yeah, and it smells kind of chemically, like I would not want that as a candle. It smells, okay, so I used to work in an escape room that was over a Subway sandwich shop. And that is to say that everyone really wanted to get out because the roasted bread makes you hungry. And this smells like 2-day-old Subway sandwich bread smell.
It does a little bit.
So-
I was gonna go with vomit, but that's a much more negative.
So
way
to
put it.
me, that smells horrible to me.
Really? Like
Do
insufferable?
you? It smells pretty bad to me.
Can we watch you sniff it? We all want to watch you sniff it.
I spilled this in my bathroom.
Oh, yes!
For a while, and now whenever I walk in, it smells like this. It smells really bad. So, do you guys? I have another question for you.
Okay.
Asparagus pea.
Yes, I have
Do you have it? Do you smell it?
This can't end.
Yes.
This is pee.
How?
There's no like the next show is like you made me smell pee. I don't trust you.
Well, Dylan, last time you kissed me. This
That's
time
fine.
we make you sniff pee. So next time it's just going right up to the clouds, baby.
Okay. All right. Well,
It's
let's
not
let Russell
pee.
finish his presentation.
It's not pea.
All right.
You're welcome. So, does asparagus pea smell really bad to you?
Like, it's not, I wouldn't want it as a candle.
Okay, so this is not asparagus pea, but it is dimethyl sulfoxide, which is a metabolite created in your body when you eat asparagus that causes the smell, was one of the things that causes the smell in asparagus pea, and it's found in your urine. So for a long time, people were trying to figure out why when you eat asparagus it causes this smell. And it turns out there is a single nucleotide polymorphism that causes somebody to be able to produce this compound in your urine. So,
What a great X-Men power.
you know what? It's not only that, there's actually another one too, which allows you to create it, but also to smell it. So there's actually two things going on here. Actually, I put this in because I always am curious about like how they study this thing. And so, can you just go ahead and read this for me, Alex? Just a couple seconds.
Mitchell et al., 1987, fed asparagus to 800 volunteers. I hope they paired it with red wine in a nice state. And then collected their urine. 3 smellers then smelled their asparagus urine in a controlled sample of normal urine. Hey man, I know you're a grad student and you really needed some cash. Don't ask why. Don't ask why. Just shut up and smell this pee, okay, bud? Classified the urine simply as smelly or not. Don't tell us what it smells like. Just tell me if you don't like it. All of the smellers agreed about the classification of all the samples, which is a good indication that this was a really cruel thing to do. A good indication that urine can be classified into 2 discrete types. Of the samples, 43% produced stinky. They couldn't come up with a better scientific term than stinky urine.
Wow. Damn.
Science.
Wow. I don't even. Nah, man. But just keep going. Just keep going.
Chucking, buddy.
So so the thing that determines this is one, if you can even produce the smell. So some people don't even produce it. But then the other is whether you can even smell it or not. So, they have to find the smellers in the first place. They don't always find the smellers. All right, and the last thing before we get out of here, I want go get that last test tube from there.
Do something with this. I don't want to keep holding.
Yeah, just throw it back in there.
All right.
Is it this one?
Yeah, go ahead and take those strips out,
Okay.
and you can taste one of those.
Oh, no.
Is it LSD?
Maybe.
Should I do this too?
Yeah, both of y'all can do it. And if anybody else wants to do this, you guys can do it as
Too
well.
much effort. This is just paper, my friend.
Oh God!
Oh,
Wait, no way. Wait, does it taste like
That
something?
tastes so bad.
Are you fucking with me?
single nucleotide polymorphisms.
No way. This just tastes like fucking paper. Like,
Oh
this is
man, you know when you smell asparagus pee and it's just like it's like that. Where it's just
Wait, did you plan this? Because like sometimes they plan stuff and I don't know
no,
about
we
it.
did not plan it. Dylan is an avid Super Smash player. He's very good at Smash.
Hey.
Are you eating it?
Yes.
Oh, don't spit it out. You're just supposed to put it on your tongue
No,
and then
don't tell
All right.
Dylan what's
Well, guys, so about it now.
Okay, all right. Dylan, you know when you get hit with a Smash bat, it makes that bing
Yeah.
sound?
Is that what it felt like?
That's what it tastes like.
Whoa.
It's very bad.
This is a piece of paper. He's lying to you.
So
What is this? What have I
This
invented?
is this paper is called Phenylthiocarbamide, and it's what. So what's interesting is that 75% of the population can taste it, and about 25% can't.
Oh.
You're one of those.
Dylan's special.
This
Yeah.
compound, and it is again, it's a single nucleotide polymorphism, just one little letter that allows you to taste this or not. And this is what is actually found in, like, if broccoli tastes bitter to you, or those other things, other
Like
kinds of
cilantro or no?
not cilantro,
No,
but
okay.
other kinds of cruciferous vegetables you will taste.
No one knows that word.
My son knows that word.
Okay, well you raised your son right.
Don't lie. The fact that you can't taste it means that, or suggests that you don't have the, you have the variant in this gene that doesn't allow you to.
I mean, I like straight up ate it. Like it's in my body now. I thought it was just a piece of paper. I thought this was like some weird joke.
No, it was not a weird joke to my tongue.
Damn, that's crazy.
So, just the takeaway that I want to leave with everybody is again, just all of these were just examples of one tiny little element in your DNA that causes these drastic differences. And it's just millions of these that causes it to be so individual and different from each other.
Cool. All right.
Yeah,
Thank you.
yeah, that's the beginning.
All right.